Finding a specified term of an arithmetic sequence given the first terms. Find the 50th term of the following arithmetic sequence. Okay, so we're given a sequence, and they give us the first 4 terms, and they want us to be able to jump and tell them what the 50th term is going to be. So let's look at this arithmetic sequence. First of all, they tell us it's arithmetic, which means we know we're adding or subtracting to get from one term to the next. So to get from 14 to 19, and 19 to 24, and 24 to 29, I see a pattern of adding 5. So it's an arithmetic sequence with a common difference of 5. Okay? Now, technically, in order to find the 50th term, I could just add 5, add 5, add 5, add 5, add 5, again and again and again until I got to the 50th term. Now, could I do that? Yes. Do I really want to do that? No, because that's going to take a lot of work and it leaves a lot of room for error because there's so much adding to do. So what I could do instead is write an explicit formula so that I could jump to any term value in my sequence. So let's do that. To write an arithmetic sequence, I can write it in function notation or sequence notation. I'll show you both, but I'm going to start with function notation. So I know that f of n, which means to find any term value, I'm going to take my starting term, 14, and add my common difference. Now, I'm not just going to add my common difference once because that will just give me the next term. I'm going to add this n minus 1 times because that will take me from the first term all the way out to the 50th term. Okay? So if I'm trying to find the term value of the 50th term, I'm going to take 14 plus 5 times 50 minus 1. Okay? So now I just need to do the math. 14 plus 5, 50 minus 1 is 49. So now I'm going to go ahead and get my calculator out. And I'm going to do 5 times 49 and get 245. So now I have 14 plus 245. So I'm going to add 245 plus 14, and I get 259. So f of 50, or the value of the 50th term of my sequence, is 259. So if I added 5 all the way out to 50, I would get 259 in the 50th spot. So this would be my answer. Now, if you want to see that in sequence notation, I would have put a sub n, so the value of the nth term, equals the starting value plus the common difference times, again, n minus 1. So the only difference when we do explicit formulas with arithmetic sequences is this beginning. They still both have a simple n minus 1 in the equation. So to find the value of the 50th term, I'm going to start with 14 because that's my starting value, and I'm going to add 50 minus 1 times. So I would get 14 plus 5 times 49, and 14 plus 245 equals 259. Now this math is exactly the same. I just get a sub 50 equals 259. So the answers are the same. The notation is just slightly different here. But the 50th term of this sequence is 259.